s squared plus 2 over s cubed, oh, that's factor, sorry, over s minus 1.1, that's less than s plus 1.1, s plus 2 squared, s plus 3.4. Let's say I have this. So what's the partial fraction expansion of this? Actually, let's make it cube. Okay. Yeah, let's make it.
So R1 is.
What's the partial fraction expansion for this? It's going to be, this has only multiplicity 1, so it's going to be C11 over S plus 1.1. This is multiplicity 2, so C21 over S plus 2 plus C22 over S plus 2 squared. This has multiplicity 3, C31 over S plus 3.4 plus C32 over S plus 3.4 squared plus C33 over S plus 3.4 to the cube. With me, that's the partial fraction expansion. Any questions about that? Which are candidates for the quick and easy? C33. What else? C22. Okay, the CI here. Okay? So what I'm saying is, let's say I want to find C22. For C22, multiply both sides by S plus 2 squared, the denominator of C22. Wait a minute. So the result is left hand side, since I multiplied by S plus 2 squared, this will get cancelled. So the left hand side becomes S squared plus 2 over S plus 1.1 S plus 3.4 cubed equals, and I get here C11 over S plus 1.1 times S plus 2 squared. Right? Because I multiply by S plus 2 squared. The next term has an S plus 2 in the denominator, but I multiply by S plus 2 squared. So the next term will be plus C21 times S plus 2. You see that? The next term, sorry, C, the wrong term is C21. Next one, the C22 term, I multiply the denominator, will be just C22. And then the next terms will be, let me put them all together, C31 over S plus 3.4 plus C32 over S plus 3.4 squared, trying to fit them in, plus C33 over S plus 3.4 cubed, all that times S plus 2 squared. Do you see that? Mika? So that's the result. Notice that the right hand side has S plus 2 in the numerator of every term. I have here S plus 2 squared. For C21 I have S plus 2 first power. I have bracket S plus 2 squared. So S plus 2 is a factor of everything on the right hand side except C22. So what I'm saying here, what will happen is the right hand side will be the C22 plus S plus 2 multiplying everything else. That's the point I'm making. How are we doing? Andrea. I'm multiplying, this is the partial fractions expansion, right? For the example. I want to find C2. I multiply both sides of this equation by the denominator of C2, which is S plus 2 squared. The left-hand side simply cancels that part. The right-hand side, I will cancel that part from C2. Every other term will have S plus 2, at least to the first power. If it's not an S plus 2, the denominator will be S plus 2 squared. Even this term will have S plus 2 in the numerator.
And then just solve for C2
Felix?
Is that any different from the partial fraction, the composition where you find?
Well, that's how I find the C's of partial fractions expansion.
Okay.
Okay? So, I get this equation. Now look at this equation. What's the root I have? -2. Now use S equals, okay? Then use S equals Ri, the root. If I use S equals Ri, what happens to the right-hand side? Since S minus Ri multiplies everything, as Robert says, the only thing that is non-zero on the right-hand side is Ci. And on the left-hand side, wherever I had S, I put Ri. So you can see why for C2, the result is the left-hand side putting for S R2. That's the magic. Here, if you use S equals -2, so now use S equals R2 equals -2 in this system. What do we have? Right hand side, this is 0 because of this is 0 because of this, the whole bracket times 0. So you get C2. So the result is going to be -2 squared plus 2 over -2 plus 1.1 times -2 plus 3.42 equals C2. So that's what it boils down to. You don't need to do this two-step process. You can just combine it in one step. Look at your left-hand side, hide the part of the denominator that corresponds to the denominator in the right-hand side of the expansion, and then use for S the root. That's what I wrote with words. The final result is you can just take your partial fractions expansion equation and just hide the denominator. So in this example, for C11, I would hide this and use S equals -1.11. For C22, I hide this, I use S equals -2. For C33, I hide this, I use S equals -3.4. Got it? Jeff? Angelica? Robert next to Angelica?
Can you show us how you got the last step? I couldn't follow you.
And use S equals -2, that one?
No, the one on the right. Is there a formula for that I missed?
For this?
Oh, okay. No. Yeah. Yeah.
This?
Yeah, I got everything else but that. Where'd you get that from?
Okay.
You just solved
so
for
now I'm using S equals -2, the root of C2. S equals -2 is the root,
Yeah,
right?
yeah.
So when I use S equals -2, what happens to the right-hand side? Everything goes away because I have a -2. So this is 0, this is 0, this is 0, multiplying the bracket. The only thing that doesn't go away is the C2.
Oh, okay, yeah, that's, you just solved
So the
it.
right-hand side becomes C2.
Yeah.
The left-hand side is whatever I had by hiding the S plus 2 squared using -2 for S.
Oh, okay. Got it.
You can see how much easier this is than matching coefficients. Okay?
So what do we do for the other ones?
Well, we'll get to that a bit later. So let's go to our example, because we can finish the example and get your first plot and answer your question.
Okay, yeah.
So you understand the partial fractions expansion quick
Yeah.
All right, so you have to tell me what is C11 and what is C21. Back to example. So this is, we talked about the quick easy part, right?
Mm-hmm.
So we are going now back to the example. We had stopped in the example with y prime of t equals this. On purpose I didn't erase that. Okay? And
Is C?
we basically have to find an inverse of 1 over s plus 0.11, and that has this partial fractions expansion. So now quick and easy, and I will ask for everyone here who hasn't spoken much. For C11, tell me what I hide and what value of s I use. Robert.
You're gonna hide the s, and then plug in 0 for the other s.
So what do I get?
1 over 0.111.
Exactly. Someone who hasn't spoken today, give me a hand. Ashley, with a hand?
Sure.
Okay, so C21, tell me what I hide.
You're going to hide the s plus 0.11.
Excellent. And what value of s do I use?
0. Or
Don't let someone else input.
Negative 0.11.
Exactly. What makes this denominator 0, which is the root, minus 0.111? So what's the answer?
Negative 9.
Okay, well, 1 over minus 0.11 or negative 9? Okay. Okay? So yeah, that's 9 and that's negative 9. Okay? So,
Okay, the value of s is going to be the number or what makes everything 0?
the root, which is what makes that particular denominator 0.
Okay, so if it's 0.11, it's going to be negative 0.11.
Now that's what we get. The root is minus 0.11. Right? That's the root. Not the number. The root.
Okay.
What makes this 0. Okay? Alright. So, we found the cis. Now, we can go to the dictionary. Each one of those terms,
We're going to have like 4 hours to solve the problem test.
right? So, using the quick and easy, so continue the example. You allow me to erase that. Keeping up with the notes. Okay, I'm not going too crazy with all the changes back and forth. So we have that 1 over s, that's s plus 0.111, is equal to 9 over s minus 9 over s plus 0.111. And using dictionary, follows that L inverse of and I want someone who hasn't spoken today to tell me what entry in the dictionary am I going to use to find the inverse. Okay, so let me write it so that. Okay, let me. All right, let me, not dictionary yet. So from that follows that that's equal L inverse of 9 over S minus L inverse of 9 over S or plus L inverse of minus 9. Let me write this. So, someone tell me what's that? from the diction who hasn't raised a hand before? Next.
9t.
Look,
9.
this matches dictionary how? It's this, right? It's 9 times 1 over s.
Yes.
Now let me stay with Nate. So how do I get 1 over s here? If I mean k is 0, it becomes a is 0. Okay, so what do I get from there? If you put a is 0 and k1,
B.
T.
Careful.
You got one.
No, just the minus.
You get 1, right? So it's 9 times
Yeah.
1. The inverse of 1 over s is 1. Remember, special entry 1 gives us 1 over s. So the inverse of 1 over s is 1. So that's 9. And someone who hasn't spoken at all, give me this. Let's see, who twitch? Adam.
Who twitched?
Excellent.
Keys.
So minus 9 factors out, and I have 1 over s plus 0.111. Right? Constant factors out. And then here, I'll take it. Let me do something. Equals 9 times L inverse of 1 over s minus 9 times L inverse of 1 over s plus 0.11. I just took the constants out. So, as Nate told us, L inverse of 1 over s using k1 and a0 is 1, so that's 9. And as Adam said, he has 1 over s plus 0.111. What do we need here? I need the a to be Adam, and the k to be 1. So using k1, this thing becomes 1, e to the minus 0.11.
But what is the e? Okay, there it is. You didn't write it.
Well, I stopped to ask the people what it is. I wrote the common factor.
Okay.
Okay? So, we have that inverse. So now we can write what h of t is. So h of t look from up there. My h of t is minus 5.55 times that's inverse times 10 to the minus 5. So multiply that by that, and you get this happens to be 10 to the minus 5. 10 to the 5. This happens to be 4.5 times 10 to the minus 4, I believe. So you get minus 4.5 times 10 to the minus 4, and you get 1 minus e to the minus 0.111. Okay? So, we found y prime. I'm going to verify that number. I want it in memory, but I'm pretty sure it's right. What that is missing. Oh no, wrong, 5. Minus 5 times 10 to the minus 4. Okay, 5.55 times 9 is 50.